First thing, trying to get a visual picture of what's going on in the situation. So here I got my launcher. I don't know what a launcher looks like. Something like that. Right? So it shoots this projectile in an airplane. Okay? Sound effects too. Right? And then what happens as he shoots it? After he shoots the airplane, right? Well, that 2 point, yeah, the aircraft is destroyed, so he hits the what I call aircraft.
Plus 50 points.
Then the person turns his. So I'm explaining how we're going through this. Okay. Turns it 35 degrees. So this thing sort of rotates 35 degrees because he's aiming at another airplane. Oops, over here. So the angle that he turned in between was 35 degrees. Right? So that's where that hit is. So he just turned to his right, 35 degrees, shoots an airplane. And really, the other thing that we're having in here, although that looks like a right angle triangle, it's not supposed to be. It's not implied. But we want to know the distance. So we want to solve for x. But we're only given one angle.
So we use the cosine law.
Pardon?
2.5 seconds and the 134 minutes.
So you want to use the seconds?
No, well, multiply and then you look at the.
Okay. So what is it you're trying to do?
Get the meters from the.
Yeah, so you try. Well, you want the distance, right? So you want your side lengths of the triangle to calculate that distance. So I didn't give you a distance, but I give you how fast the projectile was traveling and how long it traveled. So you have to go back and say, well, what's your distance formula? So first, let's label a triangle. So A, B, C. So this side length. So basically, I'm trying to solve for A. This is C, and this is B. So C is equal to speed times time. So what's the speed of projectile? Yeah, 134 meters per second. And it travels for how long on this first airplane? 2.5 seconds. So our units actually cancel out for seconds, and we're left with 134 times 2.5. 335? So that's how we actually calculate that distance here. So this is 335. Is that meters? Is it meters? Yeah, meters. And then we do likewise for B. So B is equal to speed times time. B is equal to 134 meters per second. Okay, this is really distracting over here. I'm sorry.
Sorry.
Are you having, what's the issue here, Ryan?
I was trying to figure out what the calculators did.
Okay, can we look at that a little bit better? 34 meters per second times 3.5 seconds. So what's the answer over here? 134 times 3.5?
469.
469 meters. So once we have that triangle, we want to find x. The first thing we always want to try to do when we're solving for a triangle, try to do something with a triangle, is not a right angle triangle, so that rules out our trig ratios right off the bat. We want to try the sine law. Okay? The sine law is a bit easier to work with than the cosine law. In order for us to use the sine law, what do you need to know? The two things. Which is? Of what? So what is it that we're looking for in that triangle?
angle and the side opposite.
Yeah, so we need to know the angle and the opposite side. So unfortunately, we know the angle, but we're looking for the opposite side, so we're stuck with the cosine law. So here, I'll do the math really quick. We got a squared is equal to the other two sides squared, minus 2 times those two sides, times the cos of the angle. So we get a squared is equal to, b is 469 squared, c is 335, minus 2 times 469 times 335 times the cos of 35. Now you can have this discussion of why you can't get the right answer in your calculator.
The cos button is broken.
Oh, that was a question on the math test.
Yeah.
Was
I
was
should
broken, so we can still.
like but it's not a right angle.
So 469 squared is 219, 961 plus 35 squared. 1122
25.
25
Yeah.
minus 257,402.15. So a squared is equal to 74783. Right, so that's what we get for a squared. Are we looking for a squared? No. Right, so we need to square root both sides. So a is equal to
273.5.
I like this calculator. Give me a square root of the answer. What is it?
273. 47.
273 point what?
47.
47.
Oh, yeah.
Okay.
Does it matter if you get like 0.1 off or 0.01 off?
I'm not worried about complete accuracy because at some point it depends where you round. When I do the math, I actually keep this part exact. Because I do all this in one shot on my calculator. And then I leave this answer in my calculator and I just do the square root of it. That's how you get the most precise answer. Some calculators, if you have an answer there, if you like do a square root, it actually does a square root of that answer that's left there. Okay? So even if this was just a question where I draw a diagram and there's units on the sides, the lengths of the side, you need to specify your units. Okay? So that's one thing I saw on the quizzes. People were leaving off the units. So if the question asked is giving you units, you need to answer in units. Okay. Any questions on this example? There's actually another way to do it. Instead of using 335, 469, you can actually use the times. So you can actually use 2.5 here, and you can actually use 3.5 here. And if you apply the cosine law to this, you get something like x equals 2.05. What does that 2.05 represent, though?
If the rocket was flying down.
Sorry?
If the rocket was flying from there to there, that's how long it would
Yeah. So what this represents, because we're dealing with time now, this represents that if this projectile was shot from this plane to this plane, it would take 2.05 seconds to get there. And then you could apply 2.05 times 134 meters per second, and you should be getting the same answer. Okay? So either way it works. Kind of cool that way. Now before I actually go on to this lesson, I want to talk about one thing. Some of you know this, some of you don't. I didn't realize that this wasn't taught before. I thought maybe it was taught in grade 8. I looked back in grade 9, and it wasn't actually taught in grade 9. Obviously, I didn't teach it in grade 10. It's just going back to proportions, ratios, solving for x, basic algebra. So if we have something like solve for x, what is it that we do?
Multiply.
We multiply, right? We want to isolate for x. In other words, we want that coefficient in front of x to be 1. In this case, it's 1/3. So what we really want to do is we want to multiply both sides by 3. Then you get left with x is equal to 50 over 8. Okay?
Can't you multiply it by 24?
You could multiply. So that's the one thing. I taught my brain as to solving equations, these exact questions. You can do anything to this equation. I gave them that power, right? Do anything to your equation. Don't have two rules, though. You have responsibilities. You need to do it to the complete side of one side. So whatever you do to one side, you need to do the whole side. But then you also have to do it to the other side, right? Those are the rules you need to keep. So in this case, we chose to multiply both sides by 3. We can multiply both sides by 24. So if we multiply both sides by 24, we're left with 8x is equal to 24 times 5 divided by 8. 24 times 5 is what?
Yeah, I'm so confused.
One
When you
here?
get rid of all the fractions.
Yeah.
You got lost here?
Oh, never mind. I got you.
Right? But what happened there, Alex, is that you got a coefficient. So multiply both sides by 24, you got 8x. Yeah, 8x. So you still got a coefficient, your 8, your x, then you have to divide it up. So this was a little bit more efficient. Okay? So most of us, if not all of us, get this. The tricky part was, I would get taught this, is you get 7 over x is equal to 11 over 13. Now what we're solving for is the denominator.
Wait, this is a new equation.
This new equation, okay? So what we're solving for is now the denominator. And I've seen this too many times. I need to address this, not just in this class, in all my classes. We try to take the same trick that we did up here. Oh, well, we see an x, we see a number. If I multiply by that number, okay? It's not a magic trick, what we did up here. You still have to do the math there. 7 times 7 does not give us 1. Doesn't get rid of our number, right? 7 times 7 is 49. The other thing is that x is a denominator. It doesn't magically move up to the numerator, which is what we've done in the next step, okay? So we can't do this. We can't do that. How do we properly solve for this? So to rewrite it. Yeah, so I'm hearing the answers cross multiply. That's not a math operation. It's a shortcut. Okay? So I want you to understand why cross multiplying works. Yes, Christian.
Can I do it?
You want to do it? Yeah, what do you want to do?
Can I write it?
What do you want to do?
Okay, so you multiply x to both sides. That is not fun.
What do you say?
Can try it.
So what you say is you want to multiply x to both sides.
Yeah.
I'll let you try another time, all right? This is really important. So I want to make sure you all got this. So what we were saying before is that you can do anything to an equation. We're just so used to, you know what, only add numbers, subtract numbers, multiply, divide by numbers. We could also do that with variables. The only thing is that you need to do it to both sides now. So the reason why we multiply here 3, because we want to get rid of the numerator. So that's the same trick that we're doing over here. We want to multiply by x, so their x's cancel. So here we're left with 7, and now we have 11x over 13. So same thing, now I have a fraction on the right-hand side. One of the tips I take on grade 9 is if you don't like fractions, multiply by the denominator. So as here we're going to do the same thing, except we're now going to multiply by 13. So here we're left with 13 times 7. We have 11x.
Why don't we just multiply that by reciprocal? Like so much easier.
Multiply by x over 7?
Like, if it was 11 over 13x.
Okay, yes, we could. But, right, I just want to demonstrate that one part. This is why the cross multiply works, because essentially this is what you're doing. Because when you cross multiply, so you cross multiply, you get 7 times 13 is equal to 11 times x.
I did not learn this.
You guys didn't learn this?
I didn't
So,
learn cross
so that's why I make sure that we go over this. So notice that we got the same thing here. 13 times 7 on one side is equal to 11 over x. 11 times x. So that's what a shortcut of cross multiplying. That is a shortcut, but really what's happening is we're multiplying both sides by 13x. Now we could go off and we want to solve for x. So 13 times 7 is 91. That's 11x. We want to isolate for x. Divide by 11. 91 over 11. Okay, very different from the answer again before. The reason I want to point this out because in the sine law we have ratios. So I saw a law of this on the quiz. We have a over sine of a is equal to b over sine of b. We're working on something else now. We know the side lengths, so maybe 3. We're trying to figure out what the angle is, big A, is equal to 5 over sine of 55, let's say. Now I'm off again. Let's just try again. Sine of A. So same principle applies here. The variable that we're solving for is the denominator. So again, I saw people multiplying both sides by 3. All of a sudden we got sine of A is equal to 15 over sine of 55. Trying to get that in calculators and get an error. Yes, because again, they understood the sine ratio. They got all this in. It was the algebra afterwards that hurt them. So here we would do the cross multiplying trick so that we would get 3 times the sine of 55 is equal to 5 times the sine of A. And now to solve for A, we need to get the sine by itself first. So same thing that we did over here, we needed the x by itself. We needed the sine of A by itself first. So we need to divide by 5 first. So sine of A is 3 times sine of 55 over 5. Calculate what that number is. 0.49 is equal to sine of A. And so now we want A, we want to do which function? Inverse sine, right? So now we got inverse sine 0.49 is equal to A. Okay? So everybody kind of get that algebra? Okay? It was important for me to discuss it because as fundamental algebra, you're going to need it for the longest time. Right? Making sure that we solve for A. Honestly, I learned that when I was in grade 7. That's why I took it for granted that we sort of knew this stuff. Okay, so we will go back and make sure we got the fundamentals down. Okay, new question.
This guy.
Solve for the following triangle. Okay, let's do this quickly.
This guy.
We got 25 minutes.
How is he?
So first of all, what does solving for a triangle mean?
Figure out
All the sides, all the angles. Because this is not a right angle triangle. First of all, it doesn't look like it. Second of all, we can't assume that it is, even if it looked like it.
It's possible.
What do we want to try to do first? First thing we want to try. Yeah, sine law, right? Sine law, the math associated with it is easy. Fortunately, we don't know any angles, so obviously we can't do. So we do cosine law. But the cosine law, we still needed an angle.
Then we solve it. We solve for it. We can do that.
There was no 10 law.
We can do that. Can we do that?
There is a sine. There is a law of tangent. I googled it yesterday.
Is it actually?
Actually, I invented it yesterday.
Bro, I said it first.
Is that what we're doing now?
Love tangent, a
I
law
invented
of
it.
tangent.
So the cosine law, what did we do? We know two sides and an angle. We solve for the other side. Here we know all three sides. So if we plug in all three sides into a cosine law, what's left unknown?
The angle.
The angle.
Tell me we're doing algebra.
So really, this is just more algebra on the cosine law. So what we're going to do is just label a triangle, A, B, C. Okay? So that makes this A. This makes this B. That makes this C. Which angle are we going to solve first? A? I like A. Sure, let's do A.
Z.
So remember the cosine law was, you're trying to figure out the side that was opposite the angle that you know. So here we don't know an angle. So we want to start off with the equation with the unknown, with the side opposite the angle, which is A. So we get A squared. So we're trying to figure out big A, so we're going to start off with little a squared is equal to B squared plus C squared minus 2BC
I like
times
this
the
question.
cos of A.
Thank you.
So complicated.
It's the biggest mission I've ever seen in my life.
That's not
Why?
so it's the cos of A. So now it's just an exercise in plugging in our numbers.
Is it 2B or 2BC?
2BC. The C got erased. So B is 13. C is 8. Minus 2 times 13 times 8. Cos of A. Yeah, we're trying to find capital A. Oh, what? I know what A squared is. That's 12.
Oh, wow. No, stop. I know what you're doing. I know what you're doing.
Alright? So I got 12 squared is equal to 13 squared plus A squared. So again, now we want to isolate for that variable. Now which one is our variable?
Cos A.
Yeah, cos A.
So we
Well, A is really our variable, but we want to isolate for cos of A. So how am I going to do that to start?
divide it.
Not
We're
quite.
gonna multiply 12.
Not quite.
Just take it off.
Yeah, all these numbers are being added. My kids call them reverse bed mass. We want to do sort of like getting the cos of A by itself first. So you need to leave all these things are the coefficients being multiplied by. We want to get rid of our 13 squared and 8 squared. So how do we get rid of my 13 squared and 8 squared?
Yes, square.
Solve it.
You add it.
Subtract.
Add each square.
Thank you. We subtracted, right?
Oh.
So we can subtract it from both sides. So I got 12 squared minus 13 squared minus 8 squared is equal to negative 2 times 13 times 8 times the cos of A.
Would it be just would it be negative 12 or just 12?
I could do positive, but
Wouldn't it be 12 just 12?
oh, sorry, it's just 12. Okay, notice I left the squares alone because I don't want to expand yet. I might make an error copying the numbers, especially with 6 digits like the last example.
I'm so confused.
Is that
You just took the exponents brought to the other side.
I did not bring anything to the other side, Michael.
Subtracted.
I subtracted 13 squared and 8 squared from both sides.
Oh.
So I subtracted from this side, D comes to 0, so I'm just left with minus 2 times 13 times 8 times the cos of A on the right hand side. Left hand side, now I want to start working things out. 12 squared is 144.
Yes,
Minus 169 minus 64. What's 2 times 13 times 8?
Negative 202.
Negative 202?
Negative 208.
Negative 200.
208?
You still fails.
So now we multiply. We add the
You added.
Well, I'm going to add the other side first. So it's 144 minus 69 minus 64.
Oh, you divide negative 208.
Well, yeah, but I want to clean up this side first. Does it have
you
a-
divide it?
I have 3 numbers being
Negative
subtracted.
89.
Negative 89?
Oh, it's positive 144.
Go negative 208.
So it's not even.
Cos of A. So now I could do isolating cos of A by dividing by negative 208. Right, so now I got cos of A.
If you just add it with that,
Sorry?
because it turns into a 0. And you have 208 on that side.
So cos of A is 89 over 208.
Oh yeah, and then you yeah.
What?
How come you know it's like negative 13 squared, negative 8 squared?
Yeah.
How come it's, you also just positive?
Because I'm minding the square.
Also, like minus
So there's really, treat it like there's brackets here. Each of those are brackets. So I got rid of my negative signs because they got really negative divided by negative gives me positive. So A is just the cos inverse of 89 over 208. So what's A?
0.427, yeah.
Sorry?
4.
I love this question.
Inverse
Oh,
cos
yeah. Okay. Forgot to do that. I can't do that. My calculator.
64.67.
Yeah, my calculator.
So yay, we got one angle.
Only 3 more to go.
Only 2 more to go.
Oh yeah. We can use.
Oh,
we
now
can
you-
use
Already
sine
failing
law.
math class.
I
What?
disagree
Use
with that
sine law.
angle with me.
Whoa, 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 whoa.
Yeah, we can use sine law.
So who says we want to calculate B now?
Sine law.
Let's do some of that sine.
Why can we use the sine law now?
Because you have
Because we
angle
have
now. Oh my god. It's a
Right?
beautiful day.
Nothing wrong. You can still calculate B using the cosine law. A lot of work, right?
Or we can do this all again for B.
But now we know one side and the opposite angle.
That's not fun. So just do this entirely. Why is there a P?
Is that your voice? Sorry, that was
Guys,
really
Please. Sine of B over sine of B is equal to A over sine of A. So B is 13 over sine of B. A was, sorry, I lost it on my screen, 12
64.67.
over sine of 64.67. Oh, so now I got, again, B is my numerator. I'm going to cross multiply. So I got 13 times the sine of 64.67 is equal to 12 times the sine of B. Then I'm going to divide both sides by 12. So B is really the sine inverse of 13 times sine 64.67 over 12. So what's B? We'll take it one step at a time. What's 13 times the sine of 64.67?
Come on, just put it calculator.
13 times 64.67 divided by 12? It's like 0.967? 0.979? So then what's B? What's the sine inverse of that? So B is 78.29.
Same. I think it's a math one there.
Woo. One more to go. So we do the sine law on angle C.
No, we just subtract that from A.
Oh, yay! Notice how that we using 3 different methods to get our angles.
Wow. Upset
This is not.
Yeah.
What?
They're all
Isn't
wrong.
it better?
It is, but
Yeah. But what-
I mean now we're using numbers we don't know our right to begin with anyways. Right? The only way we can do that is doing the cosine law 3 times. Right? So what we do is angle C is equal to 180 minus angle A minus angle B. So angle C is equal to 180 minus 64.67 minus, what's the last one? 78.29. So what's angle C? 37.
I got it, I swear to God.
Okay. So what Amy was saying is correct. Ideally, we want to always, each question, use the numbers that we know for sure. That means using the cosine law 3 times, which, given in a test, could be lengthy. So my suggestion is if you're given a question like this on a test, do it this way. Notice that the first one took a long time. Well, once we got that answer, got an easier step using the sine law, and then finally, after you finish your test, then you could go back. You know what? I'm going to figure out angle C now using the sine law. Because that doesn't take me a long time. What does that get me? Do I get the same answer? If you got the same answer, awesome. Then I'll probably go back to angle B and use the cosine law to calculate the angle B. Did I get the same answer as before? You should. If you did, good. That's sort of how we check our work doing our work. We check our work by just doing a different way. That should give us the same answer. Okay? Questions? All algebra. Let's not ask foolish questions that we know the answer to.
No.
No homework. There are no dumb questions.